All right, so chapter 6. All right. So it wants us to use words such as linear, quadratic, cubic, polynomial, degree, one variable, and two variables to describe the expressions. Does anyone have any idea what any of those words mean? We should have some idea.
Linear means that's a straight line, right?
Yep, so if you were to describe to me the function, what would it have?
F of x.
Right, it would have just an x. So linear is going to be just an x. Does anyone know what the term quadratic means?
Well, it would mean that there's 4, but that's because the x is squared, and so there's like the positive and the negative numbers because of how that works.
Yep, so quadratic is x squared. So going in that train of thought, what does someone think the word cubic could make you think of? If we have linear is x, quadratic is x squared, what do you think would naturally come next?
Is it just to the third?
X cubed, very good. So then polynomial is really any x raised to any higher power. Now there are a few other ones. They're just not used as heavily, and typically when it's raised to anything higher than 3, you can just say it's a polynomial. When we talk about a degree, we're talking about the highest degree in the order, okay? So, and I guess I should also mention that it's not going to be a singular degree, so it's a degree based on the terms. So do you see how for number C, wow, that's so hard to say, I guess 1C, you have A's and B's mixed in? You're going to look at each term. In each term, you're going to add the exponents. That helps you get the degree there. And then, of course, one variable versus two variables. One variable, you would only see one. Two variables, you would see 2 of them. Okay? They do not have to be multiplied together. They could be adding. They could be subtracting. They could be whatever you want. There's 2 of them. Okay? Okay. Highest exponent, I'm going to text that one. The highest exponent all right. Hopefully you guys understand that that means you may have to add them, okay? All right, so in fact, let's text again because it'll probably be a lot neater than my handwriting. All right, so if you guys look at 1a, it's negative 3x squared plus 8x minus 4. Using the terms that we just briefly went over, how would you describe this function? What words would you use?
Quadratic.
Quadratic.
Linear.
Can it be both linear and quadratic?
Oh no, my bad.
You're okay. So you're right, there is an x there, but what you want to look at is what is the highest x value. So if you have an x that's x squared, you're going to go with quadratic, okay? What about the degree? If you were to describe the degree to someone, what degree does this function have?
It would just be 2, right?
It's second degree. And then the last part we want to look at or talk about is the variables. Is this in one variable or is this a 2-variable function?
One variable.
One variable. Okay. So this can actually be graphed. All right. You can graph a 2-variable equation, but typically when you do that, you're going to use something called the XYZ plane. And undergraduates typically do not deal with that very often. It's much higher math that you're working with there. All right, I don't want to cut that off, so I'll move over a little bit. All right, if we look at 1b, we have 5x cubed minus x squared plus 9x plus 1. So how would you describe that?
Cubic?
Cubic? Somebody new. How many degrees? What would the degree be?
3 degrees.
Yep. So third degree. And again, it's one variable. All right. The last one I do actually want to go over, though typically I would just let you guys go without it because you could do it by yourselves. But it's a little bit interesting. How would you think you could describe this function? It's 6a to the 5th b squared minus 9a cubed b cubed minus a b to the 4th.
It would be a 2-variable polynomial, right?
It is both of those things. We are going to describe it a little additionally. I'm just trying to get my snippet to work. Just give me 1 second. Really? Do apologize. Oh, whatever. Do it later. No, I can't get back to anything. Ugh. Okay. Wow, that was annoying. Okay. All right, tell me how many degrees you would have before we go ahead and write down.
It would be 5.
Remember, we're going to wow, hold on a second. This is, my computer has just decided to go all kinds of crazy on me. Might as well do that real quick. Sorry. That went all kinds of nuts. Okay. When we were talking about degrees, remember we're going to add when we have multiple degrees, or add when we have a term that has more than one variable. So what do you think the highest degree is then? If you think about it, combining those, what would you get?
Is it 9? Or no, 6?
You want to look at 6a to the 5th b squared. So 5 and 2 will give us what?
7.
Okay, so it's a 7th degree polynomial. And you already told me it has 2 variables. Okay.
I have a question about that.
Sure.
So why do we only, why are we only adding the first 2 and not like the 9a cubed and then b cubed as well?
So you can go through and you can add all of them and compare, but typically polynomials are going to be written from the highest degree down. So in this case, we would have 7, 6, and 5. Okay. That's a great question, though. Okay, so do we need to go over combining like terms in the sense of A and B there? Actually, 2A and B, 3 and 4, they all look like they're just doing things you guys should know how to do. I will do them, but please let me know if it's necessary, because if it's not, then we'll just keep going. You also have my teacher notes. So if you really don't understand how to do that, just message me and I can either stay on with you for a few minutes after class, or, we can make time separately. But I really think you guys have been able to do that to this point. So I feel confident you can do that. All right. So if we take a look at number 5, this is kind of similar to what you guys were doing in Pearson with the linear equations, but what do you notice about this graph? What is it showing you? What's that a graph of?
It's a quadratic.
Mm-hmm. Yep. Sometimes people call it quadratic by another name. Does anyone know it?
Curve?
Not just
Parabola.
parabola. Very good. Okay. I honestly don't care what you would like to call it. Some of you could just call it a teardrop. As long as you know what they mean, I'm okay with it. If we were to find f of 4, how would we find f of 4?
We'd look at where we'd look on the parabola where it touches where x equals 4 and where y is.
So if you kind of take a look on the screen, and I can zoom in a little bit if you need me to, if that will help some of you. It would help me a little bit, I think. So yeah, if we're looking where x is equal to 4, you can kind of see, you pop right up. So what's our point there?
3.
4, 3.
4, 3. So yep. So from 4, 3, your y is just going to equal 3. Okay. All right, if we are going to find x when f of x equals -3, how many answers do you think we're going to have there? Keeping in mind this is a quadratic.
2.
2. Very good. Do you know what they are?
-2, -3, and 6, -3.
Yep. So -2 and 6. Right. And then the next two are just pretty similar to that. What's the only difference? So with, actually, you know what, we should probably go over them because they're both kind of different. What do you notice about when y equals 5?
There's only one answer.
There's only one answer. Does anyone know why there's only one answer?
Because
Is
it's
that
at
the
the
vertex of it?
Perfect. Very, very good. Okay. This is the vertex. Man, I feel like I wasn't even needed to teach class today. You guys could have just done all this in person and been cool to go. All right. What about finding x when f of x equals 6? So when y equals 6, basically right here, what do you notice?
There's no
nothing
value.
there.
There's no value. Good job, Reese. Great job. Both of you. So there is none because you have a downward facing parabola, which means once you hit the top, you're done. You can't do anything else. Okay. I do think number 6 is going to be a little bit something that we'll have to maybe discuss. Maybe. I definitely think Pearson covers it differently. Are we okay with this? We're good to clear it? Okay. It will be on the YouTube video. I'm just not going to take pictures anymore. Okay. All right, so we're looking at number 6. I think I'm gonna try to use the text box as much as I can for things. So if do we have to cover finding the equation of the sum for w plus m? I don't think so, right? You guys can do like terms. Okay. And you guys can always do stuff on your own and then check my teacher notes and email me or get a hold of me somehow if you don't understand something. If we were to perform a unit analysis on the expression WT plus M of t, does anyone have an idea of what that would be? My guess is this is coming from a PowerPoint slide. So I'm just going to give it to you. This was for millions of students. And I will write it out because we are going to use it for the rest of the questions, but I don't think I have to go through and explain how I got it. Please let me know if you do need it. Okay. All right. So if we plug in, does anyone know what we would get? They're asking for w plus m, that function, so what I just typed up top, and they want you to plug in 27. So you're plugging 27 into here and into here. And once someone gets an answer, let me know. What's up?
Would it be 28.16?
Yes. Very good. So then the meaning of that is what? This means and that's coming from the problem as well. I apologize. I really should have, and I will maybe try to remember to write down the slides that these things come from, because I know typically when I'm in class, I would just have both open so we could look at it. That's just going to mean that 28.2 million students. Okay. Again, all I did was what the operation told me to do. And we're just going to plug in again. And somebody let me know what you get.
I got 3.85.
Perfect. Okay. You can see how old this problem is. Okay. All right. Would anyone like to go over finding the products? Do you feel like that is something that the majority of you need? Yeah, you want it? Okay, cool deal. No worries. Okay, so if we are going to take the product of this, go ahead and do your numbers first. So that would give us a -8. And we're going to do our x's. So that'll give us x to the 4th. And then our y's are y to the 8th. There you go. All right. The next one, it's really all about just staying organized and together. When I do my trig, I use all the colors of the rainbow, man. I literally, my trig notes look insane. So if you have ways to stay organized, I thoroughly suggest doing that. So we're going to take 2x to each piece. So 2x times 5x squared will give us what?
10x squared.
10x squared. We remember we want to add it. Add the exponents.
4.
Well, we have 5 times 2, which gives us your 10. And then we have x to the 1st and x squared. So we want to make it x cubed. Okay. All right, and then 2x times negative 3xy, we're going to have negative 6x squared y. All right, and then we're going to take 2x times 4y squared, so just 8x y squared. I really like this green color. I don't know why. It's really cool. Then we're going to take y and distribute it across. So we're going to get plus 5x squared y minus 3xy squared, and then plus 4y cubed. All right, do you think you have anything you can combine? Take a look at what you have on your paper. Take a look at what I have on the screen. Does anything look like it is similar? Yes? Good. Okay, so maybe this one goes with this one. And this one goes with this one. Okay. All right. So we're going to keep 10x cubed. Negative 6x squared y plus 5x squared y is just going to leave us with negative x squared y. And then we have 8xy squared minus 3xy squared. It's going to leave us with 5xy squared. And then plus 4y cubed. Are we all in agreement? Definitely say if you disagree. We can go over all of it. Okay. So for finding the product for part B, someone who feels like they're pretty confident in this kind of stuff, I want you to take a few minutes and do this one on paper. And then you're going to go in and screen share when you feel like you have the problem right. And then I will let you write it on the whiteboard. And in fact, I think we're going to do that for a few things. Are we good if I erase? Are we okay if I erase? Okay. So I'm not going to allow all of you to screen share at the same time. What I am going to do is I want you guys to take a few minutes when you feel comfortable and confident with the next few problems. You may, of course, ask me questions along the way. Then I will allow one person at a time to screen share so we can get some other folks writing instead of just me. I feel like that would be a blast.
Should I draw it or type it?
Whichever you feel will be more easily readable for everybody and more comfortable for you. I promise I won't let anyone make fun of your drawing. And you can certainly discuss what you're doing as you're doing it if you like. Okay, I have to ask, do you have a pen? You're
Yeah.
brilliant. I have a pen and I still write like I'm using my mouse. You might have to send me what model pen you have, or it could just be me and user error. But wow, that looks amazing. I'm jealous. Gonna have to practice more. Oh, was that so you wrote your overall answer down first? How about, I know this is gonna be a pain in the butt, but just so everyone can kind of see what you did, maybe you can start with the problem, then yeah, kind of be a mini teacher there. You can always leave what you have and just kind of go a little bit further down and rewrite. Very good. Excellent. I was just going to ask that. Perfect, Mara. Couldn't have been any better. Okay, let's give everybody a few seconds to kind of check their work. Make sure that you ask if you have a question. Excellent job. Okay. So while you're checking 8B, who is going to be the brave soul to try 9A? And here's what I want you all to know. Whoever decides to do it, it is the first time we're seeing this together, so don't be upset if you mess it up or if you need to ask a question. It's okay, just work it out.
I'll do it.
You'll do it? Okay.
Yeah.
Mara's gonna go ahead and end her screen share, and then you should be able to take it over. Make sure you pop up the whiteboard for everybody. And I do suggest writing down the problem. Excellent. Anybody have a question on that? All right, give people a few seconds to make sure they can write it down and check their work. Okay. Anyone interested in doing 9B?
I have that one as well, if that's fine.
Yeah, why not? I'll be nice today. You can go ahead and do it. It stops the screen share having to switch as much. Excellent. One question. -4 times -4 will give you what? Excellent. Okay. All right. Somebody new. And or does anyone have any questions on this one? No questions? Then we'll allow for a new screen share. Who's going to do it? Who's going to be our brave soul for 9C? Okay, Sam.
I just don't know how to do the whiteboard thing that you guys were doing.
Okay, so if you hover at the bottom of your screen,
Okay.
it should be a green button that says screen share.
Yeah, whiteboard, right?
Yep.
Okay.
You'll click on whiteboard and click share, and it should take over. And I can also tell you guys while Sam's getting his pulled up, number 10A on my teacher page, I wrote down that it's written incorrectly, but we will go over either. It doesn't matter to me. I think I was just trying to keep it in line with the rest of 10. So I made one of them x plus 6 and one of them x minus 6. You guys know that I borrow most of my stuff from other teachers anyway.
Confusing me as I have a mouse pad.
Oh, don't worry. I'm right there with you, man. And even when I have the pen, I still write like I have a mouse. Oh, okay. The only statements I'll make real quick is that I believe on the original document it was pluses instead of minuses, which would change your middle term. And you do not have to erase it, but typically, don't forget your sixes should also be positive there. Yeah. Typically, when we write our final answer, we keep the first variable to the fourth power on the left, and then it'll have the mixture in the middle and the last variable higher power on the right. But it's completely fine. You don't have to rewrite it. You can leave it like that. It's still technically correct. It's just conventionally mathy people like to see it the other way. 100% correct though. Don't worry about it. All right. Anybody want to work on 10? And or did anyone have any questions on 9C? Okay. All right. So who would like to do the first part of 10? 10A. And you can do either x plus 6, or you can do x plus 6, x minus 6. You can pick which one you would like to do.
I can try it.
Go ahead, Reese. Very good. Now, what would be really helpful is if you could switch your colors, and then could you do for us the opposite? Could you do x plus 6 and x minus 6, but keep it so they can see both? Could you do that for us? Great. Excellent.
Does that just become an x then? Like what happens there?
Well, if you had 6x and you took away 6x, what do you think it would become?
It would just be an x, right?
Well, just an x would be 1x. But if you have only 6 and then you took away 6, how many do you have?
0.
0. Excellent. So this is typically the part where teachers like to tell you that you can take a shortcut, and that shortcut would be if you notice that it's two binomials multiplied by each other and they are identical but have different signs, you can get away with just multiplying the first and the last. However, my caveat to you is always going to be just go ahead and do it like normal, like you just did, because what happens if you get super flustered on a test and you go, oh, I can just use the shortcut, and then you miss every single problem because you did a shortcut. If you can remember it, that's fine. If not, I suggest just going ahead and doing it like normal. Very, very good job. Thank you so much for that comparison. Does anyone have any questions with either of those? No? Okay. Who would like to do the next part of 10? The multiplying is the nice part. Wait till we get to the next page. Okay, so if no one else wants to do any, I think you guys can handle B, C, and D on your own. We'll just go ahead and skip to 11. And I can take back the screen share. Did not mean to do that. Okay. All right, so we're looking at number 11, which probably, again, is coming from a PowerPoint slide. This one at least gives us a little bit more information. So you can go ahead and read it to yourselves. What we want to do is find an equation of the product function C times P, perform a unit analysis of the expression. So I think all I did for the unit analysis there is I stated that we are compare cost model versus fit of population. I think that's all I wrote there for the analysis part. And then I'm going to try to write out very nicely the answer here, which you're just taking C, which they give you, and P, which they give you, and you're multiplying. So I got 9.24 P squared plus 1087.4 T plus 22,606. Okay. And then what does part C want us to do? I don't know why it's not part B. I guess part B is this part.
You would enter 28 as your t value.
Mm-hmm. Very good. And if we do that, what do we get? What is the answer there when you plug 28 in?
I got 60,297.36.
Perfect. We're going to leave it for money purposes. I think when you're talking about millions of dollars, people don't care so much about the cents. Wish I had that problem. We are slowly getting through it. I definitely think we're gonna have to pick it up on Monday again, but I guess the question is, would you rather